Great, thanks, Bob. Good morning, everyone. It's good to be here this morning. I just flew in from Amsterdam this morning, so we had a little de-icing on the plane. But it's nice to see there's no snow here in London. eBay has a lot of data, a tremendous amount of data. And because we're data-driven, we're very motivated to innovate, not only in how we process and store that data, but also how we analyze it and use it to drive excellence at the company. So we're very, very focused on the data that we have. We're making a lot of efforts to maximize our use of that data. And I'd like to sort of scratch the surface of that today and give you an idea of some of the key components of that, even though I won't have time to go into nearly as much as we could talk about if we had several hours or days. Just to give you an idea of the tip of the iceberg of the data. Okay. So here we're talking about tens, hundreds of millions of buyers and sellers who are using our site worldwide, hundreds of millions of unique items, okay, items that fall into 30,000 categories, but most of which are one of a kind in some way, which really differentiates us from a lot of people who are working in the e-commerce space. In terms of velocity, we're looking at thousands and thousands of dollars in transactions every second across the world. So tremendous volume, variety, and velocity, but that's just the tip of the iceberg of what we have to work with. It's not even the most difficult part. What's underneath the surface for us for big data at eBay is all of the buyer behavioral data, the clickstream data, the weblog data, the online search data, which numbers in the billions per day. Okay? These are the stories of how our buyers and our sellers are engaging on our site, how they come to our site, how they're searching on our site, what they're clicking on, what interests them, and how they engage with our site. Whether or not they place an item for sale, whether or not they make a purchase, whether or not they even sign in or register, these are all the actions that they're doing. It's tremendously complex, billions of actions per day. And this, for us, is the biggest part of our data. So above the surface is our organizational data, what we need to run our business. It's structured data. It's what you think of typically in a database. Below the surface is the unstructured data, the behavioral data, the weblog data, characteristic of the internet space. The volume of this, we're looking at over 50 terabytes of data coming into our system every day. 50 terabytes of data, if you've studied a little bit about big data, you have an idea of the volume of that. If not, that's roughly, by some estimates, 5 times the Library of Congress. If you believe IBM's estimate of all of the data that's created worldwide in the world, we've got 0.002% of it from eBay. Not only is that new data coming in, but we're running that data over and over again in our systems at the rate of 100 petabytes per day. So a tremendous amount of data coming in, tremendous amount of data being analyzed every day. So in this talk, I want to talk about three main points I want to touch on. First, why we're so interested in big data at eBay. And then talking about the challenges and the technologies that help us work with this. First of all, why are we so interested in some of these aspects of big data? So I'm going to ask for a show of hands here. Everyone here who, within the past 12 months, you've purchased an Apple product. MacBook, iPhone, iPad, you've purchased it. Okay, that's a pretty high number. Think of all the details involved with that transaction. Okay, what you bought, where you bought it, how much you paid for it. Is it a lot of information? Not a lot of information. Okay, I could probably pass around 2 or 3 sheets of A4 and get all that information on there. Also, not a whole lot of insight. Okay, so next question, how many of you have considered purchasing an Apple product in the past year? You've considered it. I think probably everyone. The rest of you just don't feel like raising your hands, probably. But stop to think about everything involved with that consideration process. Every time you typed a search into Google or Bing or Yahoo, went to an e-commerce site, okay, every comparison you made, anytime you read a tech review, a user review, a seller review, anytime you sorted based on price, sorted based on distance, delivery time, everything involved in that online transaction. Think about what you did over the past year. Compare the data involved with that second question versus the data involved with the first question. Compare the insights from those two. And you can see why we're so interested in that user behavior data much more than just the transactional data, because this is what's going to give us insights into our customers' intentions, preferences, and decision-making, It's going to allow us to improve our site, better enabling buyers and sellers to connect. It's going to give us the test bed for our sophisticated data mining algorithms, and a lot of other algorithms I'll mention later. And it's going to give us also a way to innovate quickly, to try new things out and know in a matter of hours or days whether a new feature will work or not work, rather than having to wait till quarter end to see the transactions. So this is really what motivates us to put so much effort into mastering our data, all of our data, not just transactional data, not just operational data. We're very demanding in what we want, and there's quite a number of challenges in this. So I mentioned the magnitude of the data that's coming in. I mentioned 50 terabytes a day, but actually storing this amount of data is not difficult. Okay, storing tens or hundreds of petabytes of data is not difficult. Okay, what's challenging for us, and what we've really had to work out in the past couple of years, is first of all to make sure that our service is reliable. We're using a lot of this data to operate our business, and it has to be reliable and dependable. Second challenge, and this is really one of the biggest challenges, which Bob touched on, is to be able to take this massive data, store all of it, and retrieve all of it in realistic time frames. Not just the operational data, but also the clickstream, the weblog, the behavioral data. Third challenge is we want to do more than just query data. We also want to run advanced algorithms on it. That's typically not going to happen on a database. And lastly, we need our users to still have the agility and flexibility that they want from a database, from a sort of personal database. So these are the four main challenges we're going to touch on that we're addressing. And we've come up with different solutions for each of these. And in the end, you'll see how, through a long process, we have a combination of systems which sort of meet these different needs. First, reliable service. I talked about the volume of data. But in addition to that, our systems are running servicing platforms around the world, 24/7, constant sales, constant uptime. There's no time for batch windows. If we do a backup, it has to happen in real time. Okay, it has to be up. It has to be reliable. Thousands of analysts around the world are accessing this data constantly with millions of queries per day. And our system has to handle this. What's even more interesting and more unique, this is the second challenge that we have, and it's dealing with this issue of structure and making a trade-off between either pre-processing our unstructured data, our clickstream data, the weblog, behavioral data, either pre-processing it and then being able to answer questions quickly, or not pre-processing it and potentially throwing out information. No, I'm sorry, I said that wrong. Not pre-processing it, keeping all the information, but not being able to access it in real time. Okay, let me illustrate that with an example. So here I've got a mosaic, tens of thousands of tiny stones. Together they form a pattern, they tell a story, they make a picture. Okay, the sequence of the colored stones make up a story. So what's interesting in this to you? Okay, sorry? The story. Right, well, it might be the number of people, okay? Maybe the number of people is interesting, maybe the number of trees. Maybe you're counting the number of stones. I want to know how many different colors there were in this mosaic or how many stones in total. There could be 100 things. So what I do is I take this mosaic, I answer the question, I write the answer down in my database, I throw out all the stones, I get the next mosaic, do the same thing. I've got 3 billion of these coming in every day. 3 billion. At the end of a couple weeks, I can answer questions in aggregate that I asked up front. I can answer how many people were there over the past 3 weeks. But if you ask me a new question, I'm lost. If you ask me how many pets, how many trees, whatever, if I didn't start with that question, I won't be able to answer it later. But now 85% of our analytic workload is new and unknown. We're answering new questions, asking for new solutions, and that's not going to work for us if we start throwing away data in order to put it in our data warehouse. The alternative is I store all of my mosaics whole. I put them all, I rent out a huge space the size of North Ireland. I put all those tens of billions of mosaics in there. Now a month later, you come back to me with a question and say, tell me how many people were in these mosaics. And I say, hey, no problem. I've got all the answers. I've got all the data. So I go back. It takes me 3-4 days to work through all those mosaics and get you an answer. You ask me another question 6 months later, it's hopeless. Okay? So this is the difficulty we have dealing with the structure. The third issue, of course, is we want to be able to run data mining. We want to be able to do trust and safety, fraud detection, image analysis, social patterns, all these things which take advanced algorithms. We're probably going to code those in a language like Java or C++. Those probably are not going to run well in a database. We want an environment where we can run those against our big data. And the fourth issue is that our analysts and business users want a database that meets their personal needs. They want the agility and flexibility to be able to add capacity, add their own data, assign privileges, and run reports without waiting several weeks or months for our central database team to give them that capacity. So these are the four demands that we have. And I'd like to tell you a little bit about how we go ahead and address these, because it's been a long process of coming up with solutions. First one, just very briefly, this is sort of the bread and butter thing. We've got it for the tip of the iceberg, the structured data that we run operations and analytics, basic analytics from. We've got a massively parallel database system. We've chosen Teradata. It works very well for us. We started 10 years ago with this, scaled it up from 14 terabytes 1,000 times in the past 10 years, about 1,000 times the size. A lot I could say about this, but I won't because it's not really unique to eBay. What's more unique is, let me just mention what this gives us. It gives us fantastic ability to do our basic operations, but we're losing storage, we're losing flexibility. Cost is prohibitive for us to store everything, so we were sampling a lot of our data and throwing the rest away. Flexibility, we're losing the ability to deal with the unstructured data. It needs to be structured to be put in our Teradata Enterprise Data Warehouse. And we're also losing the CPU ability to run our algorithms. So what we did about 5, 6 years ago is we started an internal project, which we dubbed Singularity. And what we did is we knew we had hundreds of trillions of behavioral interactional patterns. And we wanted to be able to store all those, not lose the picture by imposing a structure, but we wanted to be able to get the structure out at runtime when we knew exactly what the question was. So we wanted to put as little structure as possible on it, store all of our data, and then be able to pull data out quickly. So that was the Singularity project. We considered all sorts of different options, building from scratch, existing project, or a vendor solution. And what we finally ended up doing is working together with Teradata, and we used their off-the-shelf software running on commodity Dell or HP hardware, worked with them to develop several hundred additional special functions which suited our needs, so UDFs, if you will, and special name key value pairs. So working together with Teradata, we were able to develop this hybrid system, which was much more cost effective and could scale up to much larger volumes of data, letting us keep all our unstructured data and not throw away the data like we were doing before. And in addition, we programmed it with capabilities which would let us do what we wanted with the unstructured data. So for example, let's say we're running a query asking about the top items displayed on a given date. I won't go into the details of this, but this type of question would be very, very hard to do with a traditional structured data warehouse. There's too many name value pairs, and the data is just huge. We're running this against essentially our basic unmodified data, so we haven't pre-processed it. And you can see the magnitude of the data here. Okay, billions of page views in one day. Top items are shown tens of thousands of times. And then now we're getting what we want. With this system, we're getting a runtime. We're getting an answer to this question in half a minute. Okay, we had to work hard to get to this point, to develop this system, to get the special functions and work with our vendor to get this hybrid sort of appliance system. But now we're getting our runtime, and we can ask these questions and do our analysis in real time. For comparison, if we ran this on Hadoop, this is about half an hour on Hadoop. Okay, so Hadoop could do it, but you can see the difference. Now this slide's a little dated. Hadoop is making progress, and I think our friends from Cloudera are also going to talk about that a little later. But for comparison, you can kind of see why we're going this direction, or why we went this direction with this special system. It gave us the storage and most of the flexibility we needed, but not yet a place to run our data mining algorithms. And that's where we went to Hadoop. And again, this is a very, very common theme here, and I'm not going to spend a lot of time on it. But I will say that adoption of Hadoop has really grown a lot at eBay. We started in 2007. Our research lab out in San Jose started with a 4-node cluster. Pretty soon, the search team was using it. Now, more and more people are using it. From 4 nodes, we're up to several thousand nodes. Colossal storage, you're looking at about 80 petabytes of data. The types of jobs we're running on it are also increasing. It used to be mostly MapReduce. Now it's more and more things like Pig and Cascading and Hive. The number of users has grown to about 1,000 now. Number of jobs tripled, I think, between January and July this year. So it's just a lot more adoption for a lot of different reasons. So what are we doing with it? Yeah, we're doing all sorts of things. Like I said, the research lab, the search team, but also now fraud detection. We're looking at image analysis, network graph analysis, all sorts of things that we want to code in Java and run against our big data. So that adds the CPU, tremendous CPU ability, more than we can utilize, essentially, and fills out the gap that we had in our big data solution. So those 3 systems combined have different purposes. They each have different strengths and weaknesses. We've got the data flowing back and forth between them for different reasons. And I'll show you another scheme at the end to give you more of an idea of that. But there's still a hole here in terms of usability. And this is where I want to mention our private data cloud that we have. So essentially, about 5 or 6 years ago, about the same time we were looking at the Singularity project, we also did an analysis of the virtual data, or the data marts that we had across the group. So we had a central data warehouse, this Teradata data warehouse, but each of our business units would have their own data marts for their own flexibility, their own purposes. They'd take some central data, they'd put their own data in it, they'd give permissions, take away permissions, run their own analysis and query. Big central data warehouse, small data marts around. But then we started realizing some major problems with this. What are the problems? Well, one, of course, you've got too much redundancy. You've got extra DBAs. You've got data that's repeated 10 to 20 times because it's duplicated. But even worse than that, we started realizing that the core central data that was duplicated wasn't even matching up everywhere. Okay, so everyone had their own copies of the same data. Those copies of the same data didn't always match because bugs would creep into the load processes. So we'd be getting different units giving reports that didn't match up. Okay, so the cost, the additional resources, that wasn't the problem, but the complexity of it was a logistic nightmare. Okay, so the question is, how do you deal with the solution? So if we told everyone you have to use our central data warehouse, it's too slow of a process. Then they're waiting weeks or months to get their needs met. So this is where we moved instead into this private data cloud. Okay, so the difference here is instead of using a database cloud like you traditionally think of, where I go to a vendor and say, can I allocate space, with all the risks inherent in that and all the other issues inherent in that, what we did essentially is we created a section within our enterprise data warehouse, which was our private cloud. We call it a virtual data mart. And now any business user across the globe can go online, and within a couple minutes, they can request an allocation of space and resources and have that granted to them. Now they have permission, they have control over that dynamically allocated database, which sits within our central database. Anytime they need central data for eBay data that they want to use, it's coming straight into their virtual database from our central database. Okay, so we're maintaining the data integrity. In addition, what we're able to do is we're able to dynamically allocate our resources. So different units, of course, are maxing out capacity on their databases at different time. If they have separate databases, there's not much you can do to share that capacity. Now that they're all sitting within the same larger database, if one of them has spare capacity, then we can easily reallocate that in seconds. So that, for us, really meets that need of providing the personal, flexible, agile database needs of our different units while maintaining the big data integrity, and also giving them access to the incredible querying power of our parallel database system. How does this all fit together? The final slide is just to illustrate where we are with that. On the left, we've got a variety of data sources, from the weblog to our operations, external data that we're bringing in, local data from the business analytics. And you can see that's flowing into different places, being processed in different places, back and forth between them. And our analysts, our casual users, our power users can access any of those directly. So it's quite a system, I think. And we've come a long way to get there. And I think we've made a lot of innovations. But of course, the future is, there's always continued progress to make and continued things to try out. But I think we're really headed in the right direction. And yeah, I think it's going pretty well. I don't have time to take questions now, I think. But here's my contact details. And if you have any questions, feel free to grab me in the hall. Thanks.